Baalbek, which is located in Lebanon, and I had the great privilege of going there in September of last year, exactly 1 month before things kicked off in Israel with the whole Hamas thing. And if I hadn't got there then, I wouldn't have no chance. Like right now, Israel's bombing Lebanon.
What if I told you that 3 stones on Earth are heavier than anything modern engineers dare to move? And history claims they were lifted 2,000 years ago by hand. No legend, no warning signs. Just an impossible stone sitting in silence, daring us to explain it. For centuries, the Trilithon at Baalbek has been treated like a footnote. But when you stop and do the math, something breaks. The physics don't cooperate, the timelines don't line up. And now, artificial intelligence has re-examined the evidence and reached a conclusion no textbook is prepared to defend. So here's the question no one wants to ask. What if one of humanity's greatest engineering feats doesn't belong to the civilization we've been crediting all along? The weight of impossibility. Before we can understand why the AI findings are so devastating to conventional archaeology, we need to fully grasp what we're dealing with, because the numbers alone tell a story that words struggle to convey. The Trilithon consists of 3 limestone blocks forming part of the western foundation wall of the Temple of Jupiter at Baalbek.
Okay, we are looking at the Temple of Baalbek. Started in the 1st century, this modern construction.
Each stone measures approximately 64 feet long, 14 feet high, and 12 feet deep. Engineers who have studied them estimate weights between 800 and 1,000 tons per block, depending on the exact density of the limestone. These aren't rough estimates based on eyeballing the stones from a distance. Modern scanning technology has mapped every surface, every contour, every cubic meter of these monuments down to the centimeter. But here's what most people don't realize. The Trilithon stones aren't even the largest at Baalbek. They're just the largest that somebody actually managed to move. The foundation contains dozens of additional blocks in the 300 to 400 ton range, any one of which would represent a serious engineering challenge by ancient standards. And in the quarry itself, about half a mile from the temple complex, lie 2 even more massive blocks that ancient workers cut from the bedrock but never transported. The first is called the Stone of the Pregnant Woman. It weighs approximately 1,000 tons. The second, discovered more recently during excavations, is called the Stone of the South. It weighs an estimated 1,650 tons. That makes it the largest worked stone block ever discovered anywhere on Earth. Larger than anything in Egypt, larger than anything in Peru, larger than anything human beings have ever successfully moved without modern industrial equipment. These quarry stones sit exactly where ancient workers left them thousands of years ago, their tool marks still visible on the surface, their unfinished edges still bearing witness to whatever process cut them from solid bedrock. Let me help you understand what 800 tons actually means in terms you can visualize. A fully loaded Boeing 747, fueled up and packed with passengers and cargo, weighs about 440 tons at takeoff. Each Trilithon stone weighs almost twice that. Picture 2 jumbo jets stacked on top of each other. Now imagine dragging that combined weight across rough terrain using nothing but ropes and wooden logs. That's what the conventional explanation asks us to believe. The largest mobile cranes operating in the modern world can lift around 10,000 tons.
Welcome to the practical assessment video for the mobile crane.
But they require massive steel counterweights, sophisticated hydraulic systems, reinforced concrete foundations, and teams of engineers with advanced degrees operating computer-controlled machinery calibrated to tolerances measured in millimeters. The Romans had none of this. What they had, according to ancient sources and physical evidence from archaeological sites, were cranes based on designs documented by the Roman architect Vitruvius. Modern engineers have painstakingly reconstructed these cranes using period-appropriate materials and tested their actual capabilities. Under ideal conditions, with multiple cranes working in perfect coordination, Roman technology could lift perhaps 100 tons, maybe slightly more with exceptional effort and favorable circumstances. That's still 8 times less than what a single Trilithon stone requires. So the conventional explanation doesn't rely on lifting at all. Instead, it proposes sliding the stones horizontally using wooden rollers on lubricated tracks, with massive teams of workers pulling ropes in coordinated effort across the distance from quarry to construction site. Engineers who have calculated the forces involved estimate you would need somewhere between 40,000 and 60,000 workers pulling simultaneously to move an 800-ton block using this method. Picture that scene for a moment. 60,000 human beings, roughly the population of a small city, all gripping ropes attached to a single stone, all pulling in the same direction at the same moment, all coordinating their effort with perfect synchronization across rough, uneven terrain using nothing but voice commands and hand signals. This is where the AI analysis began, and this is where the problems started multiplying faster than anyone anticipated. When simulations meet reality, in 2023, researchers from MIT and the Technical University of Munich deployed machine learning algorithms to analyze every documented attempt at moving massive stones using ancient or recreated ancient methods. They compiled data from experimental archaeology projects worldwide, cases where modern researchers actually tried to replicate what ancient builders supposedly accomplished. The AI processed hundreds of experiments and identified a clear pattern. Successful stone movement using pre-industrial methods topped out at approximately 200 tons under ideal conditions with massive labor forces and extensive preparation. Beyond this threshold, every documented attempt either failed outright or required modern equipment intervention to complete. When the AI calculated probability distributions for successfully moving 800-ton stones using Roman-era technology, the results were damning. Less than 2% probability of success even under perfect conditions. And perfect conditions never exist in the real world. The researchers published their findings in the Journal of Archaeological Science in early 2024, using the careful language academics employ when they're saying something controversial. They wrote that the conventional explanation for Trilithon transport requires revision and that current models do not adequately account for the observed reality. Translation: this doesn't work, and we don't know how they did it. But the transportation problem was just the beginning. A 2024 study by engineers at ETH Zurich used AI-enhanced physics modeling to simulate every proposed transportation method in the archaeological literature. They tested the ramp hypothesis, the roller hypothesis, the sledge hypothesis, and various combinations. The AI ran millions of simulations with varying parameters for ground conditions, material strength, labor coordination, and equipment durability. The results were consistent across every method. None of the proposed approaches achieved successful transport in more than 15% of simulations, even with optimistic assumptions. In most simulations, the stones became immovably stuck. Infrastructure failed under the load, or the required labor forces exceeded what could physically fit in the available space. The AI identified problems that human researchers had overlooked or underestimated. Ground compression, for instance. 40,000 people standing on wooden rollers attempting to pull an 800-ton stone would cause the soil to compress and deform. The rollers would sink. The stone would embed itself in the ground and become impossible to move further. Modern engineers who move comparable weights use steel tracks on reinforced concrete foundations. The Romans had access to neither steel nor concrete in the quantities required. Then there was the turning problem. The route from quarry to temple site isn't straight. It includes at least 2 significant direction changes. Turning an 800-ton stone on rollers or sledges requires completely different force vectors than straight-line movement. The AI calculated that attempting such turns would almost certainly cause the stone to shift unpredictably, crack under uneven stress, or become completely uncontrollable. Modern engineering accomplishes such maneuvers using powered equipment and hydraulic systems with precise computer calculations. The Romans would have needed to do it with human muscle and wooden equipment while somehow maintaining the precision required for stones that needed to fit together with millimeter-tight joints at their destination. The AI calculated that successfully transporting all 3 Trilithon stones from quarry to temple using documented Roman methods would have required 10 to 15 years of continuous effort with massive labor forces working every day. Yet historical records mention no such sustained project. Archaeological excavations have found no remains of the infrastructure such an operation would require. No fragments of thousands of wooden rollers, no evidence of lubrication facilities, no worker camps capable of housing tens of thousands of laborers, no massive ramps that would have been built and then demolished. The absence of evidence isn't proof of impossibility. But when the physics says it can't work, the simulations say it won't work, and the archaeological record shows no trace of it working, the conventional explanation starts looking less like history and more like wishful thinking. Marks that don't match. The quarrying mystery deepened the problem considerably, because if transporting the stones seemed impossible, the question of how they were cut in the first place opened an entirely new dimension of uncertainty. In 2024, a team from the University of Cambridge deployed computer vision AI to analyze high-resolution 3-dimensional scans of the quarry stones. They weren't looking at the stones themselves so much as the scars left behind on their surfaces. Every tool leaves a signature. Every cutting method produces characteristic patterns. And those patterns, preserved in stone for millennia, can tell us exactly how ancient workers separated these massive blocks from the living bedrock. The AI was trained on thousands of examples of tool marks from documented historical quarrying operations spanning multiple civilizations and time periods. Roman marks from quarries across the former empire, Greek marks from sites predating Roman conquest, Egyptian marks from the pyramid building era.
But though ancient Egyptian civilization lasted for nearly 3,000 years,
medieval marks from cathedral construction, modern industrial marks from mechanized stone cutting, the system learned to identify the distinctive patterns left by different tools and techniques with extraordinary precision. Bronze chisels leave different signatures than iron tools. Iron tools produce marks distinct from steel implements. Hand cutting with hammers and wedges looks nothing like mechanical sawing or abrasive grinding. The researchers fed the AI everything we know about ancient quarrying, then pointed it at Baalbek and asked a simple question. What tools made these marks? When the AI analyzed the Baalbek quarry stones, the results didn't just contradict the textbooks. They contradicted centuries of confident archaeological attribution. The marks did not match Roman quarrying techniques documented at dozens of other sites across the ancient world. Roman quarries typically show unmistakable evidence of systematic wedge and split methods. Workers would drill holes in careful lines along the plane where they wanted the stone to break. They'd insert wooden wedges into these holes, then soak the wood with water. As the wood expanded, it would crack the stone along the predetermined line. Alternatively, they'd hammer metal wedges with increasing force until the rock surrendered to physics. It's effective, well-documented, leaves characteristic evidence, and was used throughout the Roman Empire for centuries. The Baalbek quarry stones show something entirely different, smooth, flowing cuts that suggest a sawing or grinding action rather than splitting. Continuous grooves rather than the punctuated impact marks of wedge and hammer work. Surfaces that appear to have been separated from the bedrock by some kind of sustained cutting force, moving steadily through solid limestone. The AI compared these mysterious marks to its entire database of quarrying signatures from every era and civilization. The closest matches came not from Roman techniques, but from much earlier methods, possibly Bronze Age or before, that used abrasive sawing with hard stones or sand-based cutting compounds dragged back and forth across the rock face. These methods are slower but produce smoother cuts. They're also far more primitive than what the supposedly sophisticated Romans should have been using. But here's where the mystery deepens into genuine impossibility. Some cut surfaces at the Baalbek quarry showed precision that shouldn't exist in ancient stonework, regardless of which method was used. The AI detected flatness deviations measured in millimeters across surfaces spanning multiple meters. Picture a stone face the size of a bedroom wall that varies from perfectly flat by less than the thickness of a few coins. That kind of precision would be impressive for modern industrial stone cutting with laser-guided diamond saws. For ancient quarrying using any known method, it appears not just unlikely, but genuinely anachronistic. Roman quarrying typically produced rough surfaces that would be dressed and finished later at the construction site. That's why Roman buildings often show tool marks where stones were shaped to fit after transport. The Baalbek stones tell a different story. They show pre-finished surfaces cut in the quarry itself with accuracy that contradicts everything we think we know about ancient capabilities. Whoever cut these stones achieved results that even modern commercial quarrying would struggle to match. Dr. Sarah Mitchell, who led the Cambridge study, chose her words carefully in a 2024 interview. She said that the tool mark patterns we're seeing don't fit comfortably with first-century Roman technology. Either the Romans at Baalbek possessed cutting techniques not documented anywhere else in the Roman world, techniques that left no trace in any historical record and were never used again at any other site. Or these stones were quarried by an earlier culture using methods we don't currently understand. Neither explanation is comfortable, but the evidence carved into the stone itself demands that we choose one or find a third option that nobody has yet imagined. This raised a possibility that mainstream archaeology has been reluctant to consider seriously. What if the Romans didn't build the foundation at all? What if they arrived at Baalbek centuries after the heavy lifting was already done, found an impressive platform already in place, and simply decided to build their temple on top of it? The dating problem. The Temple of Jupiter at Baalbek is confidently dated to the Roman period, specifically to the reign of Emperor Nero around 60 CE. This dating comes from architectural style, inscriptions found at the site, coins discovered in excavation layers, and historical records mentioning temple construction. The evidence for Roman involvement is solid and uncontested. But what if the Romans didn't build the foundation? What if they constructed their temple on existing foundations they discovered already in place? This wouldn't be unusual Roman behavior. The Romans regularly incorporated earlier structures into their buildings, particularly when those structures were impressively built and still functional. They were practical engineers, not proud pioneers. If they found a perfectly good foundation, they would use it rather than waste resources building a new one. And the evidence at Baalbek suggests exactly this scenario. The megalithic foundation platform uses completely different construction techniques than the temple structures above it. The lower courses feature the massive Trilithon stones with their impossibly tight joints. The upper structures show typical Roman construction methods using concrete, smaller stones, and different masonry styles. The transition between the two is visible and distinct, like two different buildings stacked on top of each other. Moreover, the megalithic platform is significantly larger than necessary for the Roman temple. It extends beyond the temple footprint in ways that suggest it was designed for something else entirely. Something bigger or differently configured than what the Romans eventually built on top of it. Medieval Arab historians preserved traditions claiming the Baalbek platform was built by giants before the biblical flood, by King Solomon using supernatural assistance, or by ancient peoples whose names had been forgotten. In these accounts, the Romans merely built on foundations that had existed from time immemorial. Western archaeologists dismiss these traditions as mythology and legend. But AI analysis is suggesting the medieval historians might have preserved an accurate memory of historical reality. In 2023, researchers used AI-enhanced analysis to determine the construction sequence of different parts of the Baalbek complex. The system analyzed joining techniques, weathering patterns, material composition, and structural relationships between different sections of the site. The conclusion was striking. The megalithic foundation shows significantly more weathering and different degradation patterns than the Roman temple structures. The foundation stones had been exposed to environmental wear for considerably longer than the temple remains. The AI estimated somewhere between 500 and 1,000 years longer, pushing the construction date back to a period ranging from 1000 BCE to 500 BCE, with the highest probability in the earlier range. This dating contradicts the conventional timeline, but aligns perfectly with the tool mark analysis, suggesting pre-Roman quarrying techniques. It also explains a curious gap in Roman sources. Ancient writers describe building the temple at Baalbek, but they never claim to have built the massive foundation. Perhaps because it was already there when they arrived, an inheritance from builders whose identity had been forgotten even then. Global patterns. In late 2023, researchers deployed AI pattern recognition to analyze construction characteristics of megalithic sites worldwide: Baalbek, Giza, Sacsayhuaman in Peru, Ollantaytambo, Tiahuanaco, Stonehenge, Karnak in France, dozens of others spanning multiple continents and supposedly unconnected civilizations. The AI identified distinct construction signatures, combinations of stone size, placement precision, jointing techniques, and material selection that tend to cluster together. Sites built by the same culture or using related technologies show similar signatures even when separated by centuries or vast distances. The patterns are subtle enough that human researchers missed them, but clear enough that machine learning could detect and classify them. The AI found that Baalbek's megalithic platform shares construction signatures with sites that predate the Roman period by centuries or millennia. Specifically, the foundation shows similarities to Bronze Age and earlier megalithic construction in the Mediterranean and Near East. The Roman temple structures above show completely different signatures, consistent with documented Roman methods elsewhere. This pattern reinforces the theory that the platform predates the temple and was built by an earlier unidentified culture. Even more intriguing, the AI detected subtle similarities between Baalbek's foundation construction and certain Egyptian megalithic work, particularly in the precise jointing of massive stones and the selection of specific limestone types. This doesn't prove direct connection between the builders, but it suggests that whoever constructed Baalbek's foundation possessed stonework knowledge comparable to ancient Egypt's most sophisticated builders. The AI could not identify which culture built the platform. The construction signatures don't perfectly match any known civilization in the archaeological record, but the patterns indicate builders with capabilities beyond what we typically attribute to peoples of that region and era. Someone built the Baalbek foundation. Someone with knowledge and technology that didn't survive in any form we've been able to identify. The lifting impossibility. Once the stones reached the temple site, they needed to be raised 20 feet and placed onto the foundation wall with precision measured in millimeters. This is where the conventional explanation faces its most severe challenge. The proposed solution involves massive earthen ramps built to gradually raise the stones to the required height. But AI modeling of ramp construction revealed fatal problems with this theory. A ramp gentle enough to be practical, with an incline of 7 to 10 degrees, would need to extend over 150 feet to reach a 20-foot height. For an 800-ton load, this ramp would require massive internal reinforcement to prevent collapse. The ramp itself would demand more material and labor than the temple walls it was supposedly built to construct. Multiple ramps would be needed, one for each major stone, plus extensive working space around them. After construction, these enormous earthworks would need to be dismantled and the material removed from the site. Yet no archaeological evidence of such massive earthworks exists at Baalbek. The site was extensively excavated throughout the 20th century, Archaeologists dug through layer after layer of soil and debris. They found no remains of giant ramps, no staging areas, no traces of the support infrastructure that such operations would inevitably leave behind. In 2024, a particularly sophisticated AI analysis approached the problem from a different direction. Instead of asking whether Romans could have built this, the researchers asked what technology would actually be required to build this. They gave the AI the physical parameters, including stone weights, transportation distances, and placement precision, then asked it to design a construction method that would reliably work. The AI solution required technology that didn't exist in the 1st century CE. Steel cables rated for massive tensile loads, hydraulic systems providing mechanical advantage equivalent to thousands of tons of force, precision measuring equipment for sub-centimeter alignment, and most critically, lifting methods that didn't rely solely on linear pulling force, but employed leverage and counterweight systems far more sophisticated than anything documented from the ancient world. The researchers published their findings with appropriate academic caution. The construction requirements for the Baalbek Megalithic platform exceed documented Roman engineering capabilities by a significant margin. Either the Romans possessed technology for which no evidence exists, or the conventional attribution requires fundamental reconsideration. Either way, the comfortable story is over. The explanation that satisfied textbooks for generations has been weighed by artificial intelligence and found wanting. The stones haven't moved, but our certainty has. Artificial intelligence didn't uncover a lost civilization or deliver a neat explanation. It did something far more dangerous. It proved that the story we trusted doesn't survive the math. And once one pillar of history cracks, you have to wonder how many others are quietly waiting their turn. Baalbek still stands in the sun, massive and indifferent, holding answers it isn't ready to give. We now know what didn't happen, but not what did. And that gap, that silence, may be the most important clue of all. So before you accept the next settled explanation you're handed, ask yourself this. If we were wrong about stones this large, this studied, and this visible, what else in our past is still hiding in plain sight?